20. I need 20. So this scale, sorry, the scaling I've done is no good. I have to change. My apologies. Seems I have to use very similar to what I had before. So we're going to have minus 20, 15, 10, 5, 0, 5, 10, 15, and then we have our, so this is our normal stress, and then we have our shearing stress again. Okay, shearing stress, element rotate clockwise, element rotate anti-clockwise, 5, 10, 15, 20, minus 5, minus 10, minus 15, minus 20. Okay, so our normal stress is at minus 14.948. It's approximately at 50. Okay, so this is our stress Z line. Okay, let me push this further. I think I need the more negative than positive for this case. So we still have minus 25, minus 30. Okay, then we have that is our stress Z line. And because of our normal stress in X and Y have no stress, okay, then we have 18.535. Okay, so somewhere around so this is our, this is gonna be somewhere around here. Okay. Right. So the same thing. Okay. We are going to put a pin on the center. Our pin on the center. Okay. So I'm going to do this in a 2D view. Okay. I don't want to confuse you again. So we are going to do this in the YZ plane, right? So if I have to draw this out, right? So the shear is acting in this direction. Okay, so this is our surface Z. This is our surface Y. Okay, and our Z we have a compression, right? So this shear, right, for point Z is going to induce a clockwise rotation, right, which is on the yellow, right, due to the shear. So clockwise rotation, so this is clockwise, right? So this is our point Z. Okay. So our point Y, okay, oops, I'm supposed to highlight. Our point Y, right, has the shear stress acting that direction. So if we pin on the center, right, it will tend to rotate the element in this direction, which is anti-clockwise, which is the same direction as this. This will be our point Y. Okay, and now our point X is over here. Okay, because point X has zero normal stress and zero shearing stress. So the first thing we do is we draw a line from Y to Z. You cannot draw a line from X to Z or X to Y, okay? Because on Mohr circle, one point has to be above the zero line, the other point has to be below the zero line, okay? So from here, we can calculate. So the procedure is the same. Like now you see me do the calculation, it's exactly the same like what we had, I've drawn before. So stress at of every center of the circle which is also known as our stress average, is equal to minus or stress Y plus by stress Z divided by 2. Okay, so this is minus 14.989 plus 0 divided by 2. Right, so for minus 14.989 divided by 2 is equal to 7.495 megapascal. Okay, so this is our stress average. Yeah, over here there is our stress average. Then we calculate the radius of the circle. Which is equal to tau max. So this will be equal to square root of 7.495 plus by 18.535 squared. So this is equal to 7.495 squared plus by 18.535 squared root is equal to 20. Actually, it's 19.993, but I'm going to call it 20 megapascal. Okay. Then finally, we can calculate our stress 1 and 2 principal stresses. So it's equal to minus 7.495 plus or minus 20. Okay, so 7.495 plus 20 is 12.5. Or 7.495 minus 27 point, wait, 7.495, 27.495 megapascal. Okay, so now we can construct our Mohr circle. And this one, we can construct 3D Mohr circle. Okay, so what you see over here, right, is this circle. Okay, so this value over here is equal to minus, or is our stress 1, and this value is our stress 2. And we have found from here, we have found that our tau max is equal to 20 megapascal. Now, our maximum principal stress, okay, is or for this case, our principal stresses, okay, is 12.505 and 27.495. So when you do material selection, okay, this is the one, okay, you use the highest magnitude. You use the highest magnitude because 12.505 is smaller than what? 27, right? So you use the highest magnitude to select your material. Okay. Don't look at direction for this case. Okay, you use the highest magnitude. Now, the first circle that we've drawn is this is just doing 2D. Okay. Now, if we have to consider point X, okay, into a Mohr circle, which I will later on explain more in detail, but I want you to have a look. Okay, what is it like? Okay. So this first circle over here is for the YZ plane, because it touches point Y and it touches point Z. The next circle that I'm going to draw touches the X point and the other principal stress. Okay. So this circle over here, let me use a different color. Oh, it is a different color. This circle over here belongs to the XY plane. Why XY plane? Because over here is your Y, and your Y to the principal stress, this is a what? Acute angle. Means less than what? 90 degrees. Okay, so that is why you call your XY plane, not your XZ plane. Okay, and then we can construct another circle. Okay, we can construct another circle. So let me see, 2, 4, 6, 8, 10, 11, 5.5. So the last circle that we're going to sketch on, I probably got something wrong over here. Let me count again. 2, 4, 6, 8, 10, 11. 11 divided by 2 is 5.5. Okay. Go on. Oh, no. 5. Hold on. 5.5. 4, 2, 4, 5, 5.5. 2, 4. Okay. So this over here belongs to your what? Belongs to your X, Z plane. Okay. So this is what we call 3D Mohr circle. Go on. Why do I write so badly? This is what we call 3D Mohr circle. Okay, so 3D Mohr circle does not mean it's a sphere. Okay, it just have 3 circles. Okay, we go for a short break, a 5 minutes break. We come back. I would like to do another example on compound loading. Okay, so go for a 5 minutes break and come back. Thank you.